All right, welcome everybody. How's everybody doing? You having a good time at TechEd? Worth the money? Yes. Yeah, good. That's what we want to hear. Right, good. So, thanks for coming. My name is Scott Klein. This is Grant Fritchie, world-renowned DBA. We are going to talk today about query performance tuning in Windows Azure SQL Database. So, the question is, who here is familiar with Windows Azure SQL Database?
Familiar as in you've touched it.
You've at least played with it, have something deployed, maybe not even in production, but you're at least playing with it, right? So most of you raised your hand, right?
Cool.
Good. So this will be not new to you, so we don't have to spend, that way we won't have to spend a few minutes diving into kind of an introduction of what it is. But our goals today are really to explain the importance, why we query tune, kind of the why, what, and how, right? Why are we query tuning? The tool set that we can use, the tools that are available to us to tune queries and look at troubleshooting, what's going on in our environment, why queries are running slow, how do we fix them, how do you address them, and then additional functionality, for example, things like, we don't have profiler in Windows Azure SQL Database. So how do we go look to see what's, can we look at the DMVs? What do the DMVs tell us? What do the DMOs tell us? How can we go look and dig into basically, lift the skirts and see what's going on with our environment, with our database. So kind of the why, what, and how.
Absolutely.
Right? So, Grant, want to take a few minutes to introduce yourself?
I won't take a few minutes. I'll take a couple of seconds. My name is Grant Fritchie. I work for Redgate Software. I don't put up an About Me slide, because honestly, no one cares. You guys don't want to know any history of me. What you want is a place to go to get questions answered. This is my contact information. Please, please, please use it. Track me down. You're up.
Okay, and same thing for me. I look that handsome.
He is handsome.
Right. So there's my same thing. Actually, I look like that. There's my blog, email address. I am a technical evangelist for Microsoft out of Redmond. I cover Windows Azure, and specifically the data services. So this is our cup of tea. We're database people. This is why we're doing this. So let's begin. I'm going to spend the next 10, 15, 20 minutes talking about kind of introduction, why we're going to do, kind of the tools, why we do this. And then Grant's going to take us a little deeper into look at the DMVs, about looking at indexes and weights and query stats and things like that, right? Great information. If you have any questions throughout this presentation, we like constant communication. Do not be afraid. Please raise your hand, ask questions. We like an open forum.
Who likes asking questions? Nobody. See, I love it.
Like, just give us the information. We don't get right? Just give us. All right. So why do we tune queries? So this is important. We're going to spend a few minutes and talk about the importance of tuning queries. This is not just kind of a hey, why do we don't do this? But we understand. On-prem, we know there's bad code out there. There is really bad code out there, and you can hide that bad code by throwing hardware at it, right? But just throw memory and CPU, and at some point, that's going to reach a limit of no return. You have to buy better hardware, and then at that point, you're still throwing hardware at it. So you can hide a lot of bad code, but it's important, especially in Windows Azure SQL Database, that it sort of forces you to do things the right way, and we're going to talk about why. Right? We talk about why we tune queries, because you can't hide bad code in Windows Azure SQL Database, especially now in a shared environment. So let's take a look at this, and it'll help if we spend about a minute and look at the architecture of Windows Azure SQL Database, because this is important as to kind of what's going on when we submit a query and where does it go, and kind of the architecture of Windows Azure SQL Database. So the good thing is that all your applications, all the protocols, all the languages used today still work, right? ADO.NET, ODBC, PHP, Entity Framework, all these things still work. It still talks TDS, still over 1433, all the traffic is 443 encrypted. It still works. It's all the applications still work. The difference here is, and this is where you come in as wanting to know how to tune queries, is what happens when your query comes in. We have this new services layer, and your query comes in and says, all right, what happens now? Okay? So we have the services layer, and it's responsible for provisioning, billing, metering, and connection routing, right? It's also responsible for routing your connection to the database, right? So we're not going to spend a lot of time on here, but what I want to point out here is quick pop quiz. When I create a database, how many databases do I really get? Anybody know? 3. Good. I get 3, right? 1 primary, 2 replica. My primary may very well go on the same. Yeah, 1 primary, 2 replica. Did I say 3?
Yeah, no, you
okay,
said
good.
it right.
1
yeah,
primary, 2
perfect.
replica.
Yeah.
My database may very well go on the same physical server as your database. And right now, it's a shared environment. Okay, this is important. This is why we're talking about query tuning. Right? Shared environment. So my database and Grant's database, if we put it in the same data center, could very well go on the same box. The same physical box. I don't want Grant robbing critical resources for me, and I don't want to rob critical resources from Grant.
I actually have no problem robbing them.
Yeah, that's right. I see. Okay,
I'll show you later.
Yeah. So the important thing is that, so how do we play nice in the sandbox, right? So there's, if we keep looking at the architecture, we know there is physical SQL Server. It is SQL Server 2012 running on SQL Server machines, but there's this agent called the SQL Database Fabric. And its job is to make sure we play nice in the sandbox and don't rob critical resources. But at the same time, it could be that, if Grant writes a query that's not, that's not tuned well, he could rob resources from me and start taking too many resources and make my queries run bad, right? And then there's also cost associated with this, and we'll talk about this in a minute, right? And so it is SQL Server, but it's important that we understand that when a query comes in, it goes through this services layer, and that we're all in a shared environment. So our databases could be on the same physical box, right? Okay, with that, let's talk about why we tune queries. Unlike on-premise, right? On-premise, we know there's the box. We can touch it, we can smell it, we can feel it, we can name it things. You give it instant names like Batman, Superman, Ratbert, Dilbert, things like that. You've all done that, right? We've all done it, right? But we have, in Windows, in the SQL database, we have no control where our queries run, right? We have no control right now over how many resources are dedicated to our query, how much RAM we have, how much CPU is given to our query. And if our query is written poorly, it may need more resources, which means Grant's taking more resources away from me, right? So, and then we have no idea when our server may just go away. For example, if we're always, from Windows Azure perspective, we're always looking out for your performance. So we may take your primary database and move that from one server to another server to get better performance. So that database may just go away at some point while it's failing over to another box, right? Things like that. So you don't know where it's going to run, you don't know how many resources it's going to be given right now, and your database could just go away, right? 9 times out of 10, when we get a support phone call, the first thing we ask for is, show me your query, right? Because 9 times out of 10, it's the query, right? It's not us, it's you.
Well, it's not you guys. It's those other guys that are back in the office.
Yeah, right in the queries, right? We won't blame you. It's the guys right in the queries, right? And your query could run other places. The key here is that not only do you have no control and it could be a bad query, but I think the most important point, and chime in here if I miss a point, is that tuning query in Windows Azure SQL Database actually saves you money. Can actually save you money. Anybody know why?
I mean, the key point here is DBA's in the audience. How many times have you walked up to the boss and said, hey, you know what, I can save us money by making this query run faster? Because I know I've never said that. Because it's just, well, it's running on that CPU and everything's cool. But in this place, you can literally save money because the costs for most of this is storage and downloads. Well, what's a download? A query pulling stuff down. If you get, say, deadlocks or you get really poor performance, I mean, you'd have to write a really bad query, but if you write a really bad query and you get throttled, which we'll talk about in a minute, any of these things can, or if you just have, long-running query and you lose a connection, any of that loss, you still paid for that download even though you didn't finish the query that you were running. So if those queries run really long time, you're paying a lot of cost for nothing, right? So you want those queries to run in a very fast time, return the data they need to return, and be done. So it's great. The other thing is that you do have this whole thing one of the beauties of this thing is the expandable capacity, the fact that you can just throw lots of stuff out, and that's on the next slide, so I'll shut up. But because of that, it causes one query to get run in many, many, many places. So your tuning opportunities are multiplied. You know, this query is not run in one database, it's run in 1,000 databases. And therefore, if it's running bad in one,
it's running bad in
1,000.
In 1,000.
Yeah.
Right, and it could be, you know, not only just, hey, it could time out, but you may be pulling too much data down, right? And then if it times out, you got to do it again, right? So, you know, we've seen queries where it pulls unnecessary data down. So the key here is that, you know, you want to make your query run quickly, as efficiently and quickly as possible, and only pull down the data that you need, right? So with that, then, you know, why do we use SQL database? And this should be obvious, right? Speed of delivery. How fast can I get provisioned a server in a database? This is obvious, right? I can provision a server in a database in just a matter of seconds. Extremely low management costs, right? We're maintaining, so this is physical administration versus logical administration. So we're handling the physical administration, and you guys get to do what you love to do, which is code. Do the logical administration, the logical, you know, work with the database, right? Cheap prices, so, you know, not only do we have just pay for what we use, and just if we need to expand out and scope, you know, just to pay for what we use resources, this is awesome. You guys should understand this. And then the expandable capacity. This is the elasticity. I just scale up, scale down, and just pay for those resources that I need. Grant was talking about I should be able to go from one database to 1,000 databases if I need to scale, and then go back down to one. So, you know, so just give me and let me just pay for the resources that I use. Right? So, obvious reasons why we should use SQL database. Right?
It's a huge advantage. I mean, my company's got stuff in production today. I mean, we're going in this direction because it works, right? It is inexpensive and it is easy. And if you're not a company that wants to spend lots of time managing infrastructure, this is a way out of it, right? If you're just interested in managing, I've got data, structure, and code. That's what I want to work with. Ta-da!
Yeah, don't want to have to worry about patching and licenses and all the good stuff. Let me just code. So with that, we've kind of come full circle. We saw this, you know, a decade or more ago, right? But SQL databases sort of brought back the old and made it new again, right? The concept of keeping transactions as short as possible. Execute that query, give me the data I need as short as time as possible. Lessen my cost, make my users and my CEO happy, right? Only move the data that you need to move, right? So we've written queries where we pulled too much data down, then we just kind of aggregate and okay, I only need this sort of data, right? Only move the data that you need to move and move it when you need to move it. Right? So the top three are really, really important because they kind of go in the same, right? Keep them short as possible and only pull the data that you need to move and when you need to move it. So because there's a cost and a performance associated with that, right? And it makes everybody happy, right? And then ultimately you do this by tuning your queries, right? And today what we're going to do in the rest of the time is show you the tools you can use to tune those queries, look at your poor performing queries, how to determine are you missing indexes, how to look at weight stats, do you have blocking and deadlocks, things like that, right? To be able to say, yep, I can tweak the best out of these queries.
Yeah, absolutely.
Right? So with that, let's talk connectivity. Why is connectivity so important in Windows Azure SQL Database? This is a key question, right?
I think.
So we on-prem, we know our server's right there, right? We connect to it, and really there's not really a latency or connectivity issue unless someone comes and sort of pulls out our network cable or kicks the power cord out of the back of the server, right?
I had that one.
Yeah, we sort of all had that one. The issue, when we're dealing with the cloud, connectivity becomes not a problem, but just something we need to be more concerned with or more aware with, right? And this is why we're going to talk about connectivity, because it pertains specifically to how our queries are run. What happens when we run a query, if we have to run a query again, things like that, right? So, how many of you have tried to build and code in retry policy into your application? Anybody?
In-house application.
In-house application. Anybody?
A few people. Good.
How many people loved doing that? I don't. One guy. I love.
This guy's up there shaking his head.
Yeah, he's like, I am a glutton for punishment. Yeah, I love doing that. It's not easy, is it? Right? That is not easy. Right? But it is. And when you're dealing with the cloud, this is critical. And there's certain errors that you get back. So if you're familiar with the Microsoft Enterprise Library, it's called the Windows Transient Fault Handling Application Block. One line of code that allows you to, built in right into the Enterprise Library, allows you to, has retry automatically built into it. One line of code to define your retry policy, and then it's just a wrapper around the SQL connection class. It's called Reliable SQL Connection, and you define how many times you want to retry and the number of time and the weight between retries. Done, right? And then you just, and we'll talk about codes, error codes that may come back and things like that. Because you want to, when you're coding for retries, know what kind of errors you're getting back. And there's Windows Azure SQL database errors, there's general errors, and then there's loss of connection. And these all have an effect on how your queries are run, right? Cost.
I'm sorry, I didn't mean to interrupt. Almost every one of them is going to lead to a loss of connection.
Yep.
Right? It's pretty standard. Loss of connection occurs here. I don't want to say frequently because it's not true, but when you get errors, generally they lead to loss of connection.
Yep, exactly. So there's different errors, and every single one of those has a specific code. And so the retry policy allows you to, in your catch block, say, what error code did I get back? Is it a Windows Azure SQL database error? Is it a general error? Did I get throttled? We'll talk more about throttling. Or did I get a loss of connection? And based on that information, you can retry again. Things like that, right? So please, please, please code for retries. We're not going to spend too much time on this, but please code for retries, right? Throttling. Okay, so we don't want to paint a bad picture, right?
At all.
At all. But, again, Windows Azure SQL Database wants to ensure that we all play nice in the sandbox. So if Grant's database is on the same physical server as my database, right, and if Grant starts doing something and decides to have a mean streak and decides to start doing something really mean and stupid, right, then he could get throttled. And so when we looked at the architecture, that SQL database fabric, his job is to ensure that we all play nice in the sandbox, we'll call it, on the same server.
Right.
And in part of doing that could be that Grant gets throttled. And there's two types of throttling. There's soft throttling and hard throttling. Now let me just state right up front, you really got to be doing something really, 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 really dumb to get throttled.
Or really imaginative.
Imaginative to get throttled. But it could happen, and this is why we're talking about this. Soft throttling could be things like, look, we're just going to limit the number of connections you can make, or we may scale you back a little bit and say, hey, just cool it just a minute, right? So we may, it's soft throttling is just we may limit the number of connections you can make, things like that. We don't kill any connections at that point. It's just more of a soft scaling. Okay, calm down. We may just limit the connections. Hard throttling, this is where you have just really, you've gone too far. And it could be things like, we're going to just start killing your connections, and we may prevent you from connecting any future connections for maybe several seconds, or up to 30 seconds, or things like that, right? This is because you're not playing nice. We may scale you back.
And
right?
it's literally you're using too many resources.
Too many resources.
A million locks.
For example, yeah.
Which is a huge number,
right?
Right. A million locks is hard to get to with one session. You have to be working to get there.
Yeah.
Working hard.
So now there.
Sir.
Yeah.
Load balancing in the cloud. One, that's not related directly to throttling. Two, Microsoft is load balancing its servers, but that's internal. It's not something that you're going to see. If you want to load balance through these mechanisms, you would actually have to set up some code yourself to make that happen.
Yeah, and so that's sort of outside the scope of this.
Yeah.
But we can talk to you, and happy to talk to you outside, or if we have time after, to tell you how to implement something like that, right? Because then there's the scalability aspect and how that's load balanced and things like that, right? Happy to talk to you about it.
But that does get into like the whole concept of sharding.
Sharding, yep.
And there's some really cool stuff. I mean, some really cool stuff you can do there. But
Basically,
it's a bunch of work.
Database partitioning. Right?
We're kind of focused just on the query aspect of it here right now.
But happy to talk to you about it. So again, from a throttling perspective, it does happen. There are specific error codes that come back, and this is from a query perspective to say, if I got throttled, this is kind of what Grant was talking about, the cost perspective. If I got throttled, I may have to run my query again, right? And so this is why your query tuning is critical, because if you've got a perfectly tuned query, or pretty close, you don't have to worry about it. But if you don't, and it starts taking a lot, locks and things like that, then hey,
memory,
temp DB, you're taking too many resources, you be careful, you might get throttled, right? So this is why we're talking about it. Well,
it's hard to get throttled. I've tried.
Yeah.
On his dime.
And we're actually going to try it here, and we probably won't get throttled.
Oh no, we're not. Oh no, we're not going to try it today.
Oh, not today. Oh, just throw it on the screen. Yeah. So
yeah,
okay.
Yeah.
All right. So we will take a look here in a minute at sys.event logs and sys.database connection stats.
Yeah.
These are two DMVs that give us an idea of what's going on with our connections. Were they successful? Were they not successful? Did we get throttled? Was it rejected for whatever reason? We will be able to take a look at these. These are two DMVs that you need to look at and be aware of to say what's going on with my connections, and we'll actually take a look at that. So, actually,
right now.
Okay? So, what we're going to do is we're going to jump into SQL Server Management Studio, and we're going to take a look at...
Hey, look, it's there.
Ta-da! Right. So, there's...
You're going to see an error message. This is my fault. I've been playing with stuff. Don't worry. Like I said, this is my fault. Hang on. Let me highlight that and run it.
Yep. So this is, if it hasn't timed up.
No, it's in the wrong database. That's good. That's exactly what we want to see.
Excellent.
Yeah, now we'll get the error message. And we're good to go.
We're good to go. So let's take a look at these results that came back. All right, so let's bring this up a little bit.
Control 1.
Okay, this is Control 1.
Yeah.
Oh, yeah. Whoop, there it is. All right, so here we see, look at this information. So here we see connection failed, connection successful, connection terminated, why it was terminated, event subtype, right? There's a login fail for user, connection has been idle for longer than the system needed, right? I've got an example where it says we actually rejected your connection, right, on mine. So we actually see some of these. So, connection successful, connection timeout, and in the event log, we can quickly see what is going on with our connections, what happened with our connections, and were we throttled, and possibly why we were throttled, right?
And you'll also see that it's aggregated over a 5-minute time period and brings back the count of this information for you. A couple of interesting bits here. We actually had there's 4 of us that are working off the same account. A couple of Microsoft guys, a couple of non-Microsoft guys, and one of them very helpfully changed the password. So we had connection errors occurring over and over again, so we had to go back and get the password changed back to what we all knew it was to be, and then we were able to log in again. Also, if you do get deadlocks, when you go into this window, the additional information over here on the side, oops, there we go, that additional data field, that will not be null. There will be a deadlock graph there available for you. So it's a straight XML deadlock graph. Every bit of information you would need to resolve that deadlock, it's available right there, clickable. It'll open up as XML. You can do a save as to .xsd.
XSD?
And then that will open up as a thing. We're not going to show deadlocks today, because while deadlocks is a performance problem, we're going to focus more on the query tuning aspects of stuff.
But this is a good place to start. If you're running into connection problems or you want to know what's going on, start here. And this is actually, the management portal actually pulls some of this information. But I like that blocked by firewall, right? You know what's going on by looking at this. And then lastly, let's go down and look at, what was the other one?
Switch back to editor.
Yeah, where's my mouse?
Up at the top.
There it is. And let's go down and let's run. The next one is
I just refined the query. Skip past that. There you go.
Yep, let's look at select star from sys.connection. You want the whole thing?
Yeah.
Okay, let's run at that. Okay. So let's take a look at that.
I have it, because you can keep the...
Oh, that's right.
Yeah, I cheat, because it puts it up at the top of the window.
Yeah. So let's take a look at this one real quick.
There we go.
There we go. So let's look at this. So this is tell us some other good information too. Database name, start time, end time. So kind of an aggregation of, we had successful counts, total failure counts, connection failure counts, terminated, right, over and time. So a great list of what's going on with our physical connections. We can see this actually in the management portal.
Right, and this is the aggregate. The other one is a more detailed oriented, especially because of deadlock information. This is the simple aggregate. Probably should show them in the reverse direction, because this is the aggregate and the other one's the detail, but I get more excited about the detail, so I put it first. I'm a nerd. I can't help it. The information here, though, is very useful because you want to know what's going on in the system, how connections are coming in and out, how failures are occurring, and this is where you can go to get a very fast understanding of who's connected to the system and how they're connecting. Well, not so much who, but how many.
Yeah, how many. And again, if you're, in the first one, if you're getting throttled, it'll say connection throttled, and you go, who is it and why, right? What happened, and in the additional detail, it'll tell you.
Whereas here, all you're going to see is on the throttled connection count there at the end.
Yep. All right, so
Shift F5.
Shift F5. Okay, so let's go on. Any questions so far? Okay, good. Let's keep going. We already talked about that. So tools.
Not quite there.
Not quite there. There we go.
There you
Tools.
go.
All right. So I'm assuming you're SQL people. You're all familiar with SQL Server Management Studio, so we're probably not going to spend a lot of time on that. But again, we know if you're familiar with SQL Server Management Studio, you know how to look at queries. You know how to use this great tool to look at execution plans, Object Explorer, look at tables, things like that. So we're not going to spend a lot of time on that. But there are tools other than SQL Server Management Studio to give you the information you need. And Grant's going to go into detail on one of those in one of his demos. But there are certain things you have here when we're looking at execution plans. But SQL Server Management Studio is one. The SQL Database Management Portal, has anybody seen that? Who here has wished that there was a web-based version of SQL Server Management Studio?
Quite a few. Cool. Well,
a few of you.
There isn't one. Okay, no, there is one.
So
it's just not for everything.
It's not for everything. So the SQL Database Management Portal is a web-based, sort of, we'll call it a light version of SQL Server Management Studio. It is only for Windows Azure SQL Database, but doesn't do a lot of the things. It does objects, so you can tables, views, store procedures, modify. You can write queries. You can look at execution plans, actual and estimated execution plans. I think it does almost in certain aspects does a better job than SQL Server Management Studio as far as that.
In certain ways, yeah.
In certain ways.
You're filling out the next couple of slides, so you might want to stop.
Oh, okay. Yep. Okay, so we'll stop there. And then we're going to take a look at dynamic management objects, right? So we'll take a look at a few of these. So we'll start with SQL Server Management Studio. We know this. It does require connectivity to Windows Azure SQL Database. That's an obvious one. Make sure you set the firewall rules to be able to connect. It does have Object Explorer. You can look at execution plans. You got the statistics, I/O, and time. You've all seen this. We're not going to relate that. You do have a query window. Unfortunately, you do not get the IntelliSense when working with Windows Azure SQL Database, right? But there's great products out there that allow you to do that. But beyond that, there's not a lot. So what I'm going to do is I'm going to skip this, but we'll actually open SQL Server Management Studio in another demo because I want to get to the SQL Database Management Portal.
Okay.
Okay.
Cool. I can do that.
So,
the portal. I mean, the concepts of the portal is pretty much it's still SQL Server, right? No matter what, you got to think about is that while there's conceptually some things you need to keep track of, the fact that you've got 3 databases, not one. That you don't know where those databases are running, although it may look like they're all on one server, they're not. Conceptually, there's all kinds of weird little doodads. Big picture, it's SQL Server. Anybody heard of it? Anybody?
Yeah.
Right, a couple people? Okay, great. That's good. You're going to be able to do some monitoring through the portal. You're going to be able to look at statistics time, statistics I/O. You're going to have a query window, although it does have less functionality than the Management Studio query window, and you get execution plans, which, funny enough, have more functionality than what you get with Management Studio. Don't ask me why they did that. Just say thank you. Because you can even take queries out of Management Studio window and open them up inside of the portal because it's just SQL Server. And those execution plans, the XML underneath, is exactly the same. So let's focus down on talk about the portal monitor. The information you do get is the connection activities we've already brought up, but you also get query performance. You'll get some aggregation, and you get some details on those queries, and you can see things that are occurring within it. The one bit, though, that's important to remember is that this is completely and utterly cache dependent. And so you think, yeah, okay, no big deal. It's my stuff back in my office is cache dependent too. Yeah, but back in your office, you're probably running, 100, 200 databases on a server at the most, right? These guys are probably running, I don't know how many,
A lot
500,
more than
500, 1,000, who knows? I mean, a lot of databases, and it's shared environment, right? We've brought up that several times because you got to think about the fact cache is shared. Memory is going to be shared. So cache, in this case, is going to be very volatile. It's just something that it's conceptually, this is slightly different. We have to make that leap. Cache is going to be volatile. So even though we've got access to the queries, you know, the DMOs, DMVs to get these informations back out, you're not going to see as much because of that volatility. But let's play with the code. Did it switch over? Cool. All right. So that's the demo window, and let's just go over to the demo. So obviously, you've got the basic portal. This is the normal portal. It's HTML5. It's ready to go. It's cool stuff. You can drill down and take a look at your databases. You know, we're not zoom in a little bit so you can see what we've got. We've got a few databases on here. Some are mine. Some are shared. I've got 3 different Azure accounts that I'm logged. Well, okay, I've got 4. You guys can't see my business one on here because my company would be angry with me if I did that. But these are my 2 test accounts and the one that I'm sharing here with Scott. It's useful stuff, right? But it's not that detailed. Over here, we've got the management portal for SQL Server. And now we've got more information. So you take a look at this. Just the basic summary information gives you an idea when the database was created, how much space is used, how much space is free. And everybody's going, eh, and I don't blame you. So let's take a look at the query performance. And now things get more interesting. So now you see the queries and you see stuff like run count, the amount of CPU used. Scroll on over. Duration, physical reads logical reads per second. Great stuff. If you're doing query tuning, this is the place you're going to go. The details. Well, so let's say there's a query that we're attracted by. Okay, I'm not even sure what this query is, but let's drill down on it, take a look at it. You click on it and we got errors? What the heck? Oh, it's, never mind, I know why. The thing to remember is that this is cache dependent. Guess what's not in cache anymore? The query I just tried to connect to. So let's go back to AdventureWorks. Let's refresh this. Let's pick one of the ones that has bigger run count. There we go. So now you get to see the query as it was run. Right? It's a nice simple query. This is a system query. It's selecting is Federation member from sys databases. That's internal monitoring that we're seeing occur right now. But it's kind of cool that you can actually see the internal monitoring occurring. But you can see that you've got the resource usage down here for this particular query. So you get to see duration, CPU, logical reads, logical writes. And you get to see it all laid out. Both the totals, the last run, the min, and the max. Great stuff. You also get what they call, okay, every once in a while Microsoft does some funny stuff, advanced information. Advanced information like the plan handle and the query handle. I don't know that I would call it advanced, but I would call it very useful, and thank you very much for putting it on there. It's good stuff to have because it's going to enable you to go to the query plan cache and query yourself for this information, assuming it hasn't aged out by the time you get to it. Right? That's the one trick, is this stuff can age out of cache. The cache gets very volatile. But still, having this information available, it allows you to do troubleshooting. It allows you to do tracking and understand what's going on. And the query hash and the query plan hash are going to repeat. Right? If you get that query ages out of cache, that's okay, because the next time it comes in cache, the query hash and the query plan hash will be the same. So if you've captured that information, you can reuse it to go in there and re-query the cache to find out what's going on. Is everybody okay with that? Excellent. Other fun stuff you could look at is you can look at the query plan, which you can see looks exactly like what you're used to. Right? Oh, come on, people. It totally makes sense. Logical order on that is it's got a select statement. It's going into a loop join, which goes against an index seek and another loop join. That loop join is going against a filter and a function. It's right there. It's all right there. You can't see that? Okay, well, we'll drill down on that later, since you guys are having, a little. It's there. Trust me. All right, was there any other thing else we want to show in this bit?
No,
that's it. Yeah, go ahead.
So I like the fact that right out of the gate, what you don't get in SQL Server Management Studio, so we could pull up SQL Server Management Studio, right? And basically, we understand that SQL Server Management Studio. We get the Object Explorer. We can look at query plans. But beyond that, there's really not that much that we can do with that from looking at the execution plans and
right.
maybe uploading them, right? But I love the fact that this is the SQL Database Management Portal, and let me show you where to get to that first of all.
Oh yeah, sorry.
So what I like immediately, and that's fine. So yeah, because what I like immediately is I got my servers, I have my databases. If we were going to, let's go DemoDB, is that a good one?
Sure.
Let's go into DemoDB. I can go into my dashboard and my monitor automatically, right? And see, well, we looked at the connection information. So here's my connection information. There's my deadlocks. Let me zoom in real quick. There's my deadlocks, there's my failed connections, there's my successful connections. So immediately, I don't have to go query any DMVs. I can look at it automatically and get a good idea of what's going on. Then if I want more information, then I can drill down into these DMVs and say, oh, what happened, right? So just bam, there it is right there, right? So there's the monitor and the dashboard. They kind of give you the same information, but I like the monitor because it gives you down here, it says, minutes and max and average and total, right? So on the monitor page.
And click on add metrics.
And yes, that's true. And if I want to add metrics, I can add what's been blocked by the firewall. And this is even better, throttled connections. Please add those two to your metrics, right? Because then everything's right there, and then you can go to the DMVs and look further, right?
Yeah, there's no additional cost to putting these on because it's querying the same DMVs you can query. And you'll get that throttling information right up in your eyeballs,
right?
Which you're not going to see a count above 0 most of the time.
Right.
I mean, and by most, I mean like almost never. I've tried hard to throttle, and it's difficult.
But I like at least the ability, but I like the fact that I can go in here and add those two metrics, and then just with a quick glimpse, snapshot, know what's going on with my connections in my environment, right? Now, if I want to get to the management portal, I just go over to the database itself, so like DemoDB, click on Dashboard. And then we have this link down here on the right-hand side called, well, there's two ways to get to it. I can click on this Manage button down here, right, and that'll open that page, or I can click on the Manage URL over here, right? Two ways to get to it. But by default, you need to go into here and get to that. And this brings up what I really love, which you don't get in SQL Server Management Studio, is this snapshot. Oh, where'd it go?
You want to say that?
Huh?
So you like that?
No, not that.
Okay.
That. The query
okay.
performance.
Right.
I love this because I don't get this in SQL Server Management Studio. I get this in this portal, and again, like the metrics, there it is. There's my, I can refresh. There's my top running queries. What's going on, as Grant pointed out. This is wonderful. So you've got, just in the two portals itself, a lot more than you get in SQL Server Management Studio.
Quickly.
Right out of the gate.
Yeah, I mean, it's all available in SQL Server Management Studio, absolutely.
It is,
but it's that instant in your eyeball kind of thing. Also worth noting is the fact that while in Management Studio you're used to the tabbed environment and you're working through that, it's not tabs, but it's the same concept. You'll notice we've got the different queries that we've been playing with are open and available. So I've got a query I was typing stuff into. I've got the management portal that we're looking at the query stuff, and then the query details that we looked at from the two different queries are all right here. Further, you can open queries. Oh, hang on, I used the wrong zoom button. Silly bad presenter. There we go. You click open, and then you can get in here and open up queries that you like. So let's see. I don't know. Maybe this one be a good one to have open. Hey, come on! I said open. Open. There we go. Open. So then it opens up that query, and I've got that available now inside my query window.
Yep.
So it's the way to go.
Perfect.
Oh, hang on.
Right, so, this is not that, hey, what we wanted to show you is the tools, but these are the tools that you need to be using and looking at, or should be using on a daily basis if you're using Windows Azure SQL Database to know what's going on with your queries and how to address these queries, right? So.
Sorry, I can't type to save my life. I'm screwing stuff up.
That's all right. So I think we're done with it. We can move on, I think.
Yeah, absolutely, we're done. Minimize. And Shiftify.
Yep.
There we go.
I think, main transition, I think you're up. Oh, query window, so you saw that.
Yeah.
We won't go into that. Yep, you're up.
Cool. So you've already seen the portal execution plans. I like to tease and show it a little bit and then walk away, and everybody gets all upset. And I get to have fun. Nobody likes that. Okay, I'm sorry. Apologize, I apologize. So here's the cool thing. These are underneath what you saw visually. These are execution plans. They are .xml, .SQL plan files. They are absolutely the same thing that you're used to seeing, and I will show that to you. So it's completely normal. They are graphical. They can be saved. You're not, it's like, oh, well, I'm on the cloud, I can't do stuff. No, you absolutely can. They can be saved. Not only can they be saved, they can be reopened. They can be opened here. They can be opened in, and there's some glorious third-party tools out there for exploring query plans, and that's as close as I get to saying that. Right? There are some fantastic tools out there that do this stuff, allow you to query these things, and they are absolutely the same stuff. The properties is there, and you've got this really cool thing that Microsoft calls sorting, I call highlighting. Pick the name, but it does give you added functionality you don't have normally. So let's play with it, because this is where the fun is, or at least one of the places where fun is. All right, so I've got a query here. Nothing fancy, fairly straightforward query. I'm selecting a few columns. I'm joining 3 tables together. I've got a where clause. Everybody okay with that? Normal query, no shocks, no surprises. Great. Let's highlight it. And the one trick you have to remember is not to hit Control-E, because that doesn't work. You have to click on Run. And that runs the query, and we get back our result set. And we also get back messages. So if I want to put set stats IO, set stats time on, I can get that information back in here. But what we didn't see was execution plans. So let's re-highlight that here. And then instead of clicking Run, we'll go up here and click Actual Execution Plan. Click Actual Plan. It reruns the query because it has to in order to display an actual plan. That's just how it works. And then we get that query plan window. Now you notice this one's a little different than what we showed, because the other one was more detailed. Now I can show you how that works. There's actually a zoom button, and as we zoom out, the icons change. Okay? And as you zoom in, assuming I can zoom in, there we go. As you can see, the icons actually stay the same, but more detail is revealed. So when I talked about the fact that that was a select statement, with nested loop joins, clustered index seeks, it's just because I've been looking at these plans a lot and I've memorized the icons and I can buzz through it real fast. But if I want to, I click down, zoom in, and I get exactly the same information as I'm used to seeing if we ran the same query over here, which we're going to do. Same query, exact same database, just from Management Studio. Let's turn on execution plan. And let's run the query, because you have to run the query. Now that's a normal error, because if you leave connections idle on Azure SQL Database, I actually like showing this. It's for once, I don't mind errors in my demo. Isn't that cool? They will time out. So if you get a timeout, it's no big deal, right? You just reconnect and rerun. So I'm just going to do that. And now we'll get the query that we want. What? Oh, we switched to demo DB. My bad, my bad. 1 second. Now we get the information we want. So I'll zoom in a little bit so you can see it. Exact same query plan. Yes, the icons are different. Yes, the layout is a little bit different. But this is the exact same query plan. See? No difference. Further, the good information of an execution plan. Where's the good information? Not the tooltips. The good information is in the property sheet. Now you click on one of these things, and what you get is this window that looks sort of like the tooltip. And effectively it is. There's a little less information available. Okay, no big deal, but basically it is the tooltip. But that's not what I get excited about. I get excited about this. I click View More, and now I've got the information I want. I've gone to that first operator, the select operator, which would be select, update, insert, delete, whatever. That first operator, that gives me the detail information I want, and I've still got it all within Azure. So the detail information I'm excited about, well, one is the first thing I'm seeing right here at the bottom of the screen is set options, right? The ANSI settings, because ANSI settings if you change the ANSI connection settings, you can get different execution plans and different behaviors in your queries. So knowing what the ANSI settings are for a given plan, ta-da, this is where you go to get it. If you've got two plans you're trying to compare, gosh, it's the same query. I don't know why they're running differently. Here's a first place so you can get some good information. Better still is down here looking at the optimization level, right? You get, let's see, is it click? Oh, anyway. You get to see good enough plan found. It means it went through full optimization, and the optimizer says, I did the best I could and came up with a good enough plan. Yes, it probably could have kept optimizing for another year or two and then found a perfect plan. But that's not what it does. It finds good enough plans. And so this returned back, it found a good enough plan. If it returns back timeout, that means the optimizer said, yeah, I tried and gave up. I'm not going to try anymore. Here's the best plan I have currently. And that may or may not be a good plan. That may or not be a stable plan. But you go in here and you can get the detailed information you need. Just the same way as you can do that over here. Let's zoom back out. Let's switch over to here. And you take a look at the properties. A little window pops out. Widen it so we can see it. Pin it. And zoom in. And you'll notice the information is exactly the same. Query hash is the same. The plan hash is the same. Retrieve from cache, good enough plan found, full optimization. All of the options, all of the properties available to you here are available to you in that portal. So you don't have to worry about the fact that if you go into the portal to start doing tuning, that you don't have the tool set you need. You've got it, right? It's there. But there's more. Now how much would you pay?
Yeah.
All right, there's actually a lot more. Nice view, right? You can see the query plan, you're all happy, it's good to go. Well, what if, these costs that I'm seeing here, right, these are estimated values. These are not actual costs, even though this is an actual plan, these are estimated values. And they're an accumulation of an estimated I/O and an estimated CPU. Well, what if I, instead of looking at the accumulation, I'm like, I'd rather see, I'm pretty sure that I'm hitting some I/O issues on this, and I want to see estimated I/O costs. Well, I can sort by estimated I/O. Notice it recalculates all the numbers, and it comes up with the I/O costs. Now, the I/O costs are fairly evenly distributed because I'm looking at 3 clustered index seeks, all returning a single row. Shocker. It's the same costs. Who knew, right? Who could foresee that? But if this was a more difficult plan, a more difficult query, it's going to show you more information. I can do the same thing for CPU, and now notice the CPU costs redistribute just slightly differently. The estimates are just a little bit different. It's 31.7 for one of them and 31.1 for the other two. So there's actually estimated, based on the statistics exposed by that index, the optimizers looking at possibly different choices for those different seeks. Even though they're all the same index seek against, not the same indexes, but the same type of index, there's different estimates from the optimizer, and you can expose that stuff through here. And it gets better. What if you're looking for stuff like, I don't know, let me see all the nested loop joins. Now it's highlighted the nested loop joins. The cost estimates are still there in red, but you can now see that it's highlighted in nice and blue. They call it sort or find. You can see the nested find. They changed that.
Yeah, I think they did.
Oh, God. They do that all the time, by the way. I'm doing demos, and I'll open up a screen, and it'll look different. SQL Server, Microsoft is constantly developing in this, and so little bits and pieces change all the time, which it's actually a good thing, because it's every change I've ever seen has improved. I haven't seen it yet where they've made a change, and I'm going, wow, that was stupid. No, it's every time it's gotten better. So now it says find instead of sort. Oh, that's great. Now I can't make fun of you anymore. That's wonderful.
Darn it.
Yeah, no, good job. Thank you. But if I want to, I can highlight the index seeks. Same thing, blue, right? But the red numbers still stay. So I'm not losing any bit of functionality by plugging in other little bits of functionality. And this is great because I can go in here and I can say open. And I can drill down and I can find, oh, I don't know, let's take a look for SQL plan files and see if I've got some other query plans that I want to take a look at. And I do, and I can. So notice that ugly plan. Now what if I want to look on there and say, oh, well, let me find hash matches? Any? Or was that not the right one to look for this one? No. Hang on one second. Sort operations, I think. Yeah, there we go, sort operations. So now I've got a really complex plan. It's doing a lot of functionality. I'm going to have a hard time drilling down into this, looking through it and trying to find the highest cost, trying to find the operators that concern me, right? Because certain operators are like, wait, why are we doing sorts? I don't have an order by in the query, or that kind of thing. I've now got the ability to quickly identify these things in really complex plans, right? This is an ugly plan, but now I can get into it and take a look at it very, very fast. Any questions on that? Okay, it gets better. Who here is a fan of text plans? Anybody like those? I don't personally, but I know that they are useful, and I know people like them. Well, we've got, in addition to this nice graphical plan, I can click over here, and now I get sort of the text plan. What it does is it breaks down all the operators available, and then shows the information about those operators. The name of the logical operator, the name of the physical operator, and then estimated I/O costs, the rows, estimated rows, rebinds, rewinds. So if I want to see, like, well, hang on, give me a count of the estimated rewinds. I want to see how many rewinds I've had in the system. It will reorder everything by those values, and so now I've got my operators laid out by the most rewinds, the most number that have gone over and over again, rewinding back through a data set, doing what is effectively a cursor inside my execution plan. I want to know that, and I want to track that down and figure out what that is, why it's doing it, and now I can easily, quickly. Better than text plans. This is slick. And this functionality, it's kind of funny. You can say, well, Azure, okay, fine, create one database, connect up to it anytime you need to, and instead of using Management Studio, you can use this to get through your query plans a little quicker and faster. Seriously. So, may or may not be an exciting thing. And then finally, if you're really, really, really a fan of the old style text plan, they've got this other view available that is literally a breakdown of like a folder view. And you can see how things are nested out, and you can roll them back up, say, well, okay, I know pretty much everything below this, so I'm going to roll that up and take a look at the other information available. And then that allows you to drill down and look at things like the objects being touched, and again, estimated rewinds, rebinds, the same type of information. Useful stuff, right? This is great, great stuff. Microsoft has plugged us in and fired us off, but they've only done it so far in the management portal. So that makes this a useful tool just for doing query stuff. Any questions on this? No? Anybody excited? Anybody still awake? One guy's excited. Yeah, excellent. 2 people are awake. That's good. We're doing well. I think that's all I got for execution plans. Any other questions? Cool. We will keep going. Sorry? All right, so there it goes. God, what? All right, DMO differences. You've got DMOs. You have a lot of DMOs. You even have new DMOs. But there are changes. The system level stuff that you're used to accessing is gone, right? So you don't get system level information. You just don't. You've got to deal with the fact that every database you are working on is a unique, special little flower isolated off by itself, so that each database is a database. And the information that you get about that database is only the information about that database, and you can't get information about the server that database is running on. So any of the DMOs that would expose server level information are not available to you. So what's everyone's favorite service level query? Okay, I'll tell you what mine is. Sys, DM, OS, right, operating system, wait, stats. Gone. You don't have access to it. Does anybody want to quit?
No, no, no.
Yeah, don't quit, because I've got good news too.
Luckily, we have good news.
Yeah. No, I don't have good news. I have great news. So I'll give you that in just a second. You've got to remember, though, that DMOs, like locally, you're used to DMOs failing. You know, when you reboot the server, DMO information will reset. If you fail over the server, DMO information will reset. If you attach the database, DMO information could reset. Here, DMO information is going to reset on its own when any kind of failover occurs inside of the Azure system, but you don't have control over that. So you can't count on these counters being, well, the system's been up for the last 6 years, so I should have a good set of counters. No, right? You don't know what that counter reset is, so make sure that you take that into account. Do you understand? I'm sorry, that's a bad phrase. Everybody okay with that? Okay, good. So, wait state monitoring. You still can look at system exec requests. System exec requests shows you actively running queries, and because of that, it will show you the wait stats on those queries. So it's great. But they've introduced a new DMO, SystemDB wait stats, which replaces the OS wait stats. Not only does it replaces it and makes it specific so you get waits per database. Who wants waits per database on the OS? Yeah, one guy's up there going, yeah, me too. Let's beg Microsoft. They've already got the technology. Surely they can move it down for us, right? I haven't looked at 2014 yet to see if it's there. Is it? Do you know?
I haven't looked at it.
Oh, I got to look, because that's fantastic, right? I love that. SystemDB wait stats. But the beauty is now, if you're used to saying, okay, well, query tuning starts off with determining what's causing the system to run slow, I'm going to go and look at the wait stats. You're still doing it right. And you can still do it right. You take a look at SysDB wait stats, and you get exactly what you need. Now, there are some special wait stats you need to be aware of. Specifically, you're going to see SE, REPL slow secondary throttle, SE REPL commit ACK. Basically, what these are is you've got 3 databases, right? And everybody on your server has 3 databases. As you update data on any one database, you're getting replication, and it's not. Microsoft uses the technology term replication, but the technology being used is not the replication that we all understand.
Or synchronization.
Yeah, it's some other type of replication.
Yeah.
Huh?
Yeah, it's kind of a synchronization.
Yeah. But they use the term replication for it, and don't just. I'm not saying that they're using replication. I'm not. They're using some other thing, but they call it replication. And so these are just replication weights. These are useful to know because probably in most circumstances, these are going to be your most common weight. But if you are not writing a lot of data, and you've got a lot of, especially the REPL commit acknowledged weights, that right there is an indication of what's called a noisy neighbor, meaning I'm running too many queries, but he's getting slowed down, right? Mm-hmm. So you get a lot of commit, but you're not doing a lot of writes. That's some information to check out. Wait types that you would expect to see, stuff that you should normally see, the stuff that you would normally look for. Resource semaphore, I/O latch, all the I/O latches, SOS scheduler yield, all 4, of course, memory, I/O, and CPU. Normal weights that you would expect to see. And yeah, there's going to be parallel weights, CX packet weights, all that fun stuff. It's all going to come up in the same way. Questions? Cool. What's the solution if you have a noisy neighbor? If you really are pretty sure that you've got a noisy neighbor, contact Microsoft support. They will check. They've got a series of mechanisms that will allow them to check. If you do have a noisy neighbor, one of the 2 of you will be failed over to another server. Mm-hmm. Probably the noisy neighbor, I would assume, but I don't know that for a fact. What? Hit Alt-Tab. Actually, I'm just going to use Management Studio because I like the other one for doing execution plans, but Management Studio, I at least get my keyboard shortcuts. And I'm really bad that way. I like my keyboard shortcuts. So I'm not going to insult your intelligence. I'm just going to run this query once. SystemDB wait stats. The beautiful thing is you get back what you would expect to see. And so I can see, I've got waiting tasks, page I/O latch, I'm hitting a few, lock scheduler waits, a few, And definitely I've got the SE REPL commit acknowledged there at the bottom, and it's one of my higher weights, although my main weights is the shared I/O latches. Normal query stuff, right? Now, I don't want to insult your intelligence by going through this. I just want to show you that it's available, it's easy to access, and it's completely, you know, there for what you need. And it's the same type of weight stats querying that you're used to doing, you get to do here. It's great, right? I mean, it's just great. If you're a nerd like me. Anything else on that one, Scott?
Nope. I think it's good.
Cool. Oops, one of my hidden slides is not hidden. There we go. Okay, we're in the queries, right? The query DMOs are working exactly as you would expect them. Oh, did we not?
Yes. There you go.
That was why the hidden one was unhidden.
So no.
I'm bad. All right. So the query DMOs are exactly what you would expect, right? System exec request, what is currently running? System exec query stats, what has been running in cache aggregated. Volatile, remember. System exec SQL text, which query was run against either of these, either the request or the query stats. Query plan, you can pull the query plan right out of cache exactly as you do with your on-premises SSMS. No difference, right? The queries are the same. And then is system exec query plan text, which I like to use if I'm searching for a particular operator. I wonder how many scans I've had. I wonder how many timeouts I've had. I wonder how many plans with timeout I've got. It's very fast to query system exec plan text for a string value, whereas if you try to do the same query against query plan, you've got to do X query queries, and by the way, on your production servers, those can cause problems, right? Because it uses up more memory, blah, blah, blah. So this is a quick way. The system exec query plan text is very handy because it does affect things. Just never forget that these things are affected by cache, so you won't always see what you expect to see. And now this is my fun moment. This is the moment Scott hates me.
Never.
Because what I'm going to do is I'm going to open up PowerShell. Anybody seen PowerShell this week? It's the first time? Okay, nuts. Okay, so what I've got here is I've got a little connection up to my PowerShell, to my Azure database, and I'm just running invoke SQL command on a loop, a bunch. All right? And I'm downloading all the data to my laptop right here. So let's run this. And this is evil of me, I know, and I don't apologize, but this is going to run, and what I'm doing is I'm running a whole bunch of queries against Azure, but I'm running it on his dime.
Do I need to pull out my credit card?
Yeah, you got to get your credit card on. All right, cool. So now while that's running, and that's pulling down all kinds of data, I'm going to go in here and just see if I can get query stats. So my SPID is 60, and this SPID is 977. So immediately I captured another query that's running on my database. So I'm able to see the normal stuff I would expect to see. When did that query start running? Information like, let's hide this. And let's hide this so we can see more screen real estate. There we go. So I can see the last wait type, right? I can see if it's waiting currently, what the wait time and what wait resources are using. I can see information like, let's scroll over some more. The exciting stuff. The number of reads, the number of writes, all the cool stuff that tells me when this query is running, information about it. I can get the blocking information, all that fun stuff, exactly the same way as you do on premises. No different, really. If I want to see what's going on in the query stats, we'll take a look here. And I get back a number of different queries. Not all that exciting, really. So let's put it together and make it useful. So now what we've done is I'm combining query stats, query plan, and SQL text. I'm not going to use that where clause because it's actually for a different database. Query plan query stats, and query text. I'm going to put those together. I'm also going to do a substring to get the specific statement, because as we all know, none of our queries come back with one statement. They're always, the store procedures are multi-statement, or the batches are multi-statement. And so each of those has its own query plan. So we've got to find out exactly the query statement and the query plan for the individual query. I'm going to get the execution count, time, worker threads, all that fun stuff, and run it. And so this result comes back. And the cool part here is not the fact that I can pull back this information that I'm getting from cache. The cool part here is that I can see how volatile the cache is. That little PowerShell script that you guys saw, that's running hundreds of queries a minute, right? Not a second. I'm not that good. Hundreds of queries a minute. But if you look at the cache counts, execution counts, 10, right? That's because this stuff is aging out of cache. Despite the fact that it's getting called 100 times a minute, it's still aging out of cache because there's so much cache volatility, because in theory, every one of you has a database up there, and in theory, all of your databases have queries going, and the memory pressure on cache is extreme. So it's just something to keep in mind, is that that's pretty normal to see. But I can still capture all the information. Now, one other bit, if I run this query here, I click on Show Plan, I get XML, right? I don't get, it doesn't pop open into the nice graphical GUI thing that I'm used to seeing. No big deal. You just do a save as.sql plan file, right? Where is it? There. Right, all files. My EE plan, save. And then we'll reopen it. My EE plan. Oh, I didn't rename the file extension. Bad DBA. Save as. My EE plan dot SQL plan. That makes a huge difference. Save.
There we go.
Oh, wait. I don't think I did that right either. Yeah, oh no, there it is. Cool. Cool. And all that nasty XML was actually 2 operators. Ta-da. Okay, nobody's excited.
Yeah, that was awesome. Yeah, that was great.
Anyway, moving on.
Got your money's worth out of that one.
Yeah, no kidding. So you can also do things like this. Same type of query, pulling together the same type of stuff, but I am going against the SQL text plan this time, text query plan, and I'm looking for any timeouts that have occurred. So at any point my optimizer just gave up on trying to optimize some of the queries, this will give me that list. I probably won't get any returns on this, but I might. Let's just take a look. Oh, 1. Oh yeah, it is with the with statement. Yeah, I did have one that I intentionally set up that probably would time out. So now I can see that for the query that I ran, I've got a timeout, so it means the optimizer gave up, and this is actually a great tuning opportunity. You see timeouts on your query plans, that's the one you want to try to tune. Let's see if we got any other DMOs. Nope, that's it for the moment. All right, any comments, questions in that area? Thank you. Mm-hmm. I stink. All right, the index DMOs. We don't actually even need to go over these in all honesty, but I'm just going to tell you what they are. The operational stats, currently operating stuff. Physical stats, the current distribution of the indexes and index usage stats, what's been touched inside your database, and it is stored inside your database, so any kind of failover information doesn't matter. That stuff will be failed over as well. So all the stuff that you're used to seeing as far as indexing goes, you've got. I'm not going to show you the queries because they work exactly the same. The one thing I will point out, though, is if you do detailed on index physical stats, you know that well, you probably shouldn't run that on production. It might increase the load, blah, blah, blah. Right? Everybody's used to that? Well, okay, added wrinkle. If you run that on Azure, and you're looking at a big enough index, you might get throttled. Might. I haven't been. I've tried. I'm going to have to load up some bigger databases. I'm going to charge your credit card again.
It's still hard to get throttled. But
It's hard to get throttled. I'm just saying it's one place I have seen throttling occur, okay? But rarely, very rarely. I'm going to skip past this demo just because it's might be actually a little insulting.
Yeah, they know the DMVs.
So hopefully we hit the goals that we tried to hit today. Query tuning within Azure is really important. And best of all, query tuning within Azure literally saves money for your company. It's just no better way to put it. You save money by query tuning. And that's just a glorious message to take home to the boss. The tool set is hybrid. You can really use both and mix and match. And because of that, that gives you stuff that you don't have in SSMS. Shocking enough, it's not that, oh, well, I'll just plug SSMS in. It's a tool I'm familiar with. It's a tool I know. It works better. Well, yeah, actually not. There are things that you get inside of Azure that make it better in certain circumstances, and it's mainly around the execution plans. And then obviously the management portal interface, hopefully we saw a bit of that. Mm-hmm. Resources. I did put my blog at the top. I'm sorry.
It's all right with me.
Throw rocks at me. scarydba.com/resources. I have all this stuff listed there. I have copies of this slide deck listed there. It's also, obviously, it's going to be available from
Channel 9.
Yeah, Channel 9. Thank you. That lost that bit of brain matter. I wrote a book on query performance tuning, SQL Server 2012 query performance tuning. If you throw away the first 2 chapters, everything else is applicable. First 2 chapters is on gathering server metrics and query metrics, mainly using extended events. You can't do extended events here, sorry, but everything else is applicable. The normal queries tuning stuff, no functions on where clauses, make sure you've got an index there for your where clause or your join. All that fun stuff is all 100% still applicable. Also, if you are liking the DMOs and DMVs, Tim Ford and Lewis Davidson's book, Performance Tuning with SQL Server Dynamic Management Views, is very largely still applicable here with Azure. And then finally, Connor Cunningham, who are the other names?
I want to say Michael Thomas he wrote, but maybe not.
Yeah, I'm not sure. Connor Cunningham and several other Microsoft guys wrote a fantastic, glorious white paper. Windows, Azure, SQL Database, and SQL Server. Performance and scalability compared and contrasted. Don't get put off by a goofy name. This is an amazing piece of documentation that you want to read, right? It's horribly named, but it's a fantastic piece of information. So please, please, please go on that. And if you download the slide deck, that should be a link.
Yep.
2 minutes left. Cool. This, again, is my contact information. If you have questions, get in touch. This is Scott Klein's beautiful picture and contact information. So if you want to get in touch with Scott, you can. Please do. We are here to answer questions. He's here for Microsoft to answer questions. I'm here from a third party to answer questions. He's got a point of view that I largely agree with. I have a point of view that he largely agrees with. Mm-hmm. It's kind of fun. And but if whoever you want to go to get that question answered, get in touch with us. Next few days at the conference here, these are some of the things you can go to. Scott, you want to?
So the first one, getting the most out of Windows Azure Storage, it's kind of a, hey, if you want to know how storage works and from a performance standpoint, I just threw that up there. The lap around monitoring management and DevOps solutions in Windows Azure does touch on some of the things, briefly what we talked about, but these are 2 good sessions you want to go to. Grant and I and Tom LaRock, I'm not sure Tom LaRock, will be spending tomorrow 2 sessions talking about if you're a DBA, what does that mean? And we touch on this a little bit, but if you're a DBA, what does that mean for you when you move to Windows Azure SQL Database? So that's tomorrow morning. I think the first one starts at 8:30.
8:30. Who's all there?
Yeah, woo! Yeah.
We'll go straight there from the crew party.
That's right. So, but if you're interested in, please come to that because we touch on, hey, if you're a DBA, what does it mean for you? And we touch a lot on some of these things. And then Grant and I will be down in the expo at the Cloud and Hybrid Data Platform. And if you have any questions, again, feel free to stop by.
Yeah, I'll be hanging
And we'll
out
be
there
here after a little bit too.
Yeah, yeah. With that, we are done. We got 30 seconds left, and they will kick us off stage. So please, please, please fill out the evals on this, and you know what we got wrong. Just tell us why we got stuff wrong, because we need to improve.
Yep. But anyway, thank you very much for coming.
Thank you.
Appreciate it.